everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Seth's brother Joel. We're here to hopefully show you how to approach or help you approach SAT math questions. This is question 11 out of question 16 from a booklet that the SAT distributes for the new digital SAT, which is going to be put in the United States for high school people in winter of 2024. So here we go. It looks a little schleppy because I had to block the answer out, otherwise the screen would look horrible. So the screen already looked horrible. Anyway, here it is. Why don't you do the question, read it, stop it, and then come back. For a function f of 0 is 86, and for each increase in x by value 1, the value of f decreases by 80%. What's the value of f of 2? So as Seth would say, you just follow your nose on this, right? You don't need.
Well, you could. It's easier to follow your nose when you know that the concept of decrease by 80% means the new value equals the old times like 1 minus
right. That's
0.80.
That's what I call the shopping formula,
which is old
times 0.2
times 0.2, 2/10.
Yep.
Okay, and then we started out with f of 0 equals 86. F of 1 equals 86 times 2/10.
Right. Which we have
a
calculator, by the way. Wait, it's calculated
equals 86 times 2/10 times 2/10.
Right. Yeah.
Right? And you could calculate it or observe that each of these 2/10 is 1/5.
Right.
Equals 86 times a fifth times a fifth, which is 86 divided by 25.
Right. Yeah. So the answer is either 86. Seth wrote something, but the Ziteboard is its usual way. This application called Ziteboard is slow and sluggish, and it's going to come up soon. There it is. It just came in. So the answer is either with a calculator, 3.44, or as Seth said, 86 divided by 25. Okay, yeah, exactly. Yeah, so this is just, this is what I would call a percent question. I'm always a fan of basically taking all the knowledge, all the topics that are on the SAT and consider them draws, and you have to pull out the right draw. When you see a problem, you got to pull out the right draw. This is the percent draw. You have to understand what it means when you have to understand how to do percent problems. And specifically when, in this particular one, where something goes up or down by a certain percent. And I'm a huge fan of what I call the shopping formula, which is new equals original price or old price, 1 plus or minus D, where D is the decimal of the percent. And if
we'll call it fraction.
No, decimal.
No, doesn't have to be decimal.
Well, it's P over 100.
Yeah, P over 100.
It's my
That's
formula.
A fraction.
You could have your shopping formula. Yeah. I do my shopping formula. But the Ziteboard throws. D is the decimal of the percent. Now, why do I do plus minus? Because you have to decide. Big decision. Does the percent make the number go up, or does the percent make the number go down? And if the percent makes the number go down, it's a decrease. Use a negative sign, and it's 1 minus 0.8, which is 0.2. Do not do the thing that you may want to do, which is more maybe new intuitive, where you do 86 times 0.8. That's wrong.
If we have P percent, D.
I have to move it, Seth.
Joel's D, when we have a P percent, Joel's D is P divided by 100.
Right. It's the decimal of the percent. And in this
It's
situation,
1/100th of the percent value. It's a fraction. It doesn't have to be a decimal.
But decimals are nice because if you have a calculator, then you just plug it in, right?
Yeah.
If it's a fraction, then you have more stuff to do in the calculator.
Yeah.
So yeah. What else?
Well, it's better to use decimals than Roman numerals.
And the other thing you can do, and you should do with percent problems, and pull out that drawer, if you have time, is ask yourself, does the answer make sense? Does the answer make sense? If something goes down by 80%, it goes down by a lot. And if it goes down by 80%, a lot, then you're basically left with nothing at the end. So it makes sense that if you start with 86 and it goes down by a lot, and then a lot again, you're only left with 3.44.
Yeah, well, it gets divided by 25.
Yeah.
So if you had $1 billion and you lost 80% of your wealth one day, and then you lost 80% the next day, you'd be left with, just $1 billion divided by 25.
Yeah.
Which is 40 million.
Yeah.
Not so bad.
Not so bad. Now, if you made the mistake, which I suspect some people would, of doing this 0.8 times 86.
Oh, no.
You would be left with, but intuitively, you may notice that. That's why with percent word problems, it's really important to ask yourself, does the answer make sense? After the first day, you'd be left with 86.8, which intuitively, there's a problem there because if it goes down by 80%, you shouldn't be left with almost the same thing. I mean, 68, 86 is not that far off, right? 80% is a huge decrease. So that should be a warning. When you do percent problems, always look and see if the answer makes sense to protect you from doing the problem wrong.
Decrease by 80% means that 80% is subtracted off.
It's exactly right.
It does not mean that the quantity changes by the fraction of 80%. It does not mean that the quantity gets changed by multiplying it by 80%, which is multiplying it by 8/10. It means you multiply it by 8/10, yes, but then subtract that product from the original. And that's what decreases by 80% means.
Come to think of it, in terms of approaching it, I think most people, I would say, we always say this, you always say, stop saying this, Joel, because we have no idea what people are doing.
Stop saying this, Joel.
Thank you.
You haven't done the research.
I have not done, fine, so I'm just saying a caveat. I have no idea what I'm talking about, like most of the time. But seriously, we didn't go over the way a lot of people would do this, which is the way Seth said, which people who aren't familiar with the shopping formula, then they would do it probably the way Seth did it, where if it decreases by 80%, you have to take 80% of 86 and then subtract that from 86.
Yeah.
So maybe we should show that. Maybe we should show that because that is probably, I know Seth hates me when I say this, that is likely to be the way a bunch of people are going to do it that way. So let's show that way.
Yeah.
So what you do there is if you're dying to take 80% of something, you take 80% of 86, which again, this whole test is a calculator test. There's only one math section, and it's less time, believe it or not, than the common SAT, the one they're doing now. So that's 6880. That's the decrease. So then you actually have to go 86 minus 6880. So you can see this is a much longer way to do it. This is why the shopping formula is nice, because then you take this 11.82 and then you have to do it again. You have to take 80. I guess we have to do it, right? And then we have to multiply this by 0.8. This takes forever. Wow. Then that's the decrease of boy, that means it goes down by 8.96, and then you have to subtract 11.2 and 8.96. You have to find the difference between 11.2 and 8.96, which is going to be the 3.44, but I can't do anything because the stupid thing froze. Come on. 5, 4, 3, 2, 1, go. There we go. There you go. So this thing is 8.96. This is 80% of 11.2, which means you have to take this out of 11.2. You have to subtract that, and then you get the final answer, which I did not get. 8.
So this is not a skillful way of solving that problem.
And I even got the wrong answer.
Yeah.
So in terms of approach, learn the high suggestion, learn the shopping formula, because it makes so many percent questions really relatively easy to do. Wow, there's a million ways to make a mistake. In the end, I didn't even get the right answer.
It also helps you understand just how much you're saving or losing when you go shopping.
Yeah, so let's write the shopping formula again. So the final price when you go shopping, and also the final price when you leave money for tax or tip, is the old price, the original price, original, okay, times 1 plus or minus. I'll write D. Seth will write. How would you write it then? Okay, fine. You're a big shot. How would you write it?
It's D, yeah, sure.
Oh, really? Oh, good. You get it.
D is equal to P over 100.
Oh, yeah, fine. And then we have D is equal to P over 100. So, if anything can be learned to take away from this thing, highly suggested to learn the shopping formula.
Yeah.
But I can't resist. I just can't resist describing why the shopping formula is really comes through in what I call the backwards problem, which is the problem that's, if you don't have a shopping formula, it's a big problem to understand. This is the one where you come home and say, I only paid $25 for something that was on sale for 75%. So then they say, well, then what was the original price? How much did it cost before the sale? Mm-hmm. Well, if you don't have the shopping formula, it's a harder thing to set up. But if you do have the shopping formula, it's extremely easy. So that's new is equal to the original price, 1 minus D. What did I say? What was the percent said? Were you paying attention?
30. I think it said 75.
Oh, wow. Wow. That's solve for X. You get the answer immediately. You get to solve. With the shopping formula, you could solve this backwards problem in a second. Well, not a second, but so this is 20. Then one. Wow, it looks like it's about $100 or something. Not sure what it is. Okay, so that's why the shopping formula is really helpful, because it solves the backwards problem really easily and quickly and efficiently. And we got to find ourselves a new site, a new application, because this is insane. Okay, so then this is, anyway, Seth, any final comments as this computer thing starts?
Well, have a good weekend, everybody.
Yeah. So X is 25 over 0.25. It's Friday, so I'm just going to use a calculator. Isn't that 100? Yeah, it's 100. Okay, so you get the answer easily. Okay, have a great, Seth looks like he's shot for the week. Okay, everyone, have a great weekend. Oh, wait, we never looked at the answer. Oh, my goodness. So, here, look at this explanation. What did they say? The correct answer is that. It's given that, okay, the value decreases because the output of the function decreases by constant percentage for each 1 unit. This relationship. Whoa, they're going exponential on us. That's essentially what Seth did. Do you see the answer? Seth, are you there?
Yeah, sure.
They're going exponential on us.
It's all the way at the bottom.
They're doing sort of like what Seth did. See? Seth did it here. But Seth didn't write the exponential form. Seth did it this way, which is fine. You don't have to use this whole thing. Wow.
Yeah.
And then here it is. See the 1 minus 84?
Yeah.
Yeah. Okay, so people can read the answer. Oh my God!
It's an example where it seems quickest to solve the problem in an elementary way, and not to spend the time to translate the problem into the general form of problems like this, which is exponential change, and then think about, hey, what's the exponent or what's the base?
Right.
So
Right.
it's a test is testing your familiarity and fluency with a range of questions in mathematics.
Yeah. Right.
And the it's a matter of a person is more skilled when they know many ways to approach things and choose a way that is most efficient for the given problem.
Right. Right. That's why understanding the draws is helpful. That be familiar with each problem. It's sort of like pull out the draw and say, oh, this is the method. This is what I should think about for this problem. But you always have to be flexible anyway.
Yeah.
Notice that therefore the function should be defined by, I don't know where they put the rest of the answer. Oh my goodness, are you kidding? Oh, they have an alternate approach. Look at that. They have an alternate approach. Alternate approach. Wow, so this is how we did it. We did the alternate approach. Oh, so Seth, after criticizing them, you deserve to give them an apology because they have the alternate approach.
Well, they should have done the alternate approach first.
Right. That is agreed. And why are they doing the 17.2 thing? They to be a little more clever, they should have done 86 like you did, times 0.2 times 0.2. You don't have to actually get 17.2. That's a possible mistake. A way to make a mistake.
Yeah.
Yeah. So the better
the basic math thing is that multiplication is associative.
Right. Yeah.
Which means that associativity means that to get 86 times 2/10 times 2/10 can also be obtained by taking 86 times.
I have to move the board a little.
2/10.
Right, times 2/10, right?
Times
2/10.
2/10.
Right.
Yeah.
But you know what? I think maybe one of the reasons why they did this, and it was something that occurred to me, and I was going to mention even if they didn't, is they want to make sure that you're taking the output of the first 80% decrease and using that number again. Like you decrease that number again as opposed to doing 86 twice. Okay, that's really important. You're not doing 86 times 0.2 and then 86 times 0.2 again.
No,
you're not doing that, and I think that is really what they're trying to get across here. That you have to take this number and then hit it again with an 80% decrease.
Yeah. Well, I think I've seen calculators. I don't know if the people who use the calculators that people use on SATs now have a function for taking a percentage off or on of a number. Like you type in a number.
Oh, yeah, right.
And then type either plus or minus, and then another number, and then you hit the percent key.
Yeah.
And that will do the calculation,
right,
of adding or subtracting the given percentage of the number, which amounts to multiplying the number by one one either plus for adding or minus for subtracting of the fractional form of the percent.
Right, I've seen that. I've seen that on other I bet it is on the TI-84, which is the standard calculator,
Yeah.
not the older version. But there's a menu of options on the calculator, and I bet it's one of those menu options.
Yeah.
I don't really know for sure, but yeah.
And so if you have a calculator like that, you could simply type in 86 minus 80% minus 80%, and it should give you the answer.
Right. Yeah. It's possible. People more familiar with the T84 would know if that's one of the menu options. But there are a million menu options in the calculator.
Yeah.
Okay.
But this is that's a convenient capability for people doing shopping. We want to figure out.
Yeah.
We want to figure out. What the price is when a given percentage is taken off.
Now, you see here it says digital SAT sample. See that? On the digital SAT, they will provide, you're going to take it on a computer, and most people can take it on a computer, and they will give you a calculator on the computer that you will use. And I think you may be able to still bring your own, but you got to check all that stuff off with the SAT people and your guidance counselors.
I presume that, for the sample online SAT web system, they'll show you the calculator.
You would think so, yeah. And at some point, the SAT is going to have to provide some sort of realistic sample online test that you could practice on. Right now, they don't seem to. But you just keep looking on the internet for this. You'll see all sorts of references to the digital SAT. You will see. It's coming. Although I just heard that Columbia University just was the first Ivy League school that said they're going to make the SAT optional. Isn't that interesting? For good. So.
Yeah.
Anyway, they'll take us out of business here. At least, Okay, everyone. Please like us, dislike us, give us comments, show us, please give us suggestions how we can improve what we do. And if you have SAT math questions, please feel free to email them to satmathquestionoftheday@gmail.com. And everybody, have a great day. Bye-bye.
Bye-bye.